Assalamualaikum sir and everyone. My name is Jannatul Tabbassum Hira. Welcome to our presentation. Today we would like to talk about our presentation, and our presentation topic is 555 timer. And we would like to thank our honorable course teachers Nafiz, Ahmed, Chisty sir for giving us such this opportunity. Here is our others group member Syed Muhammad Hasnat Jamee, Rahitul Ashikin Ashik, Tanjil Hasan Sakib, Sumona Akter Juthi. Here is our content that we use for describing our presentation. First, the content is introduction to 555 timer, pin configuration, operation of 555 timer, modes of 555 timer, and lastly internal circuit and simulation. Now we will talk about introduction to 555 timer. What is the 555 timer? The 555 timer is one of the most remarkable integrated circuit ever developed. It was first introduced around 1971 by Signetics Corporations. It is used in variety of timer, pulse generator, oscillator. It is used to provide delays in oscillator circuit. Any 555 is used at commercial range of 0 degree Celsius to 70 degree Celsius. As each 555 is used at military purpose, it ranges of 55 degree Celsius to 125 degree Celsius. That's all about from me. Thank you everyone, and thank you sir.
Assalamu alaikum sir, myself Syed Muhammad Hasnat Jamee. At first I would like to thank my fellow mate Jannatul Tabbassum Hira to allow me to present my speech. In this today's presentation, our topic is 555 timer and my part is pin diagram. The 555 timer is a 8-pin DIL integrated circuit or chip. Among these 8 pin, the pin number 1 is called ground, pin number 2 is trigger, number 3 is output, pin number 4 is reset, pin number 5 is control voltage, pin number 6 is called threshold, pin number 7 is discharge, and pin number 8 is VCC. Now it comes the pin description. The number 1 pin is called ground. It is connected with the 0 volt supply. And then it comes number 2, the trigger pin. It detects 1/3 of rail voltage to make output high. Pin 2 has control over pin 6. If the pin 2 is low and the pin 6 is low, output goes stage high. If the pin 6 high and the pin 2 goes low, output goes low while pin 2 low. The pin has a very high impedance and will trigger with about 1 microampere. The third number pin is called output voltage. This output is driven to approximate 1.7 below positive VCC or ground. Number 4, the fourth pin is reset. A timing interval may be reset by driving into ground, but the timing does not begin again until reset rise above approximately 0.7 volts. Override triggers with the which overrides threshold. Control voltage. Control access the internal voltage divider. By default 2/3 VCC. Pin number 6 is threshold. The interval ends with the voltage at threshold is greater and at control voltage. Discharge. Discharge is an open collector output. May discharge a capacitor between interval in phase of output. Among the last pin but not the least is number 8, positive VCC. Positive supply voltage is usually between 3 and 15 volt. Thank you sir.
Assalamualaikum sir, myself Tanjil Sakib. I want to express my gratitude to my colleague Syed Muhammad Hasan Jamee for enabling me to deliver my statement. The 555 timer is the theme of today's talk and my part is about operation. Stable mode operation. Initial output is high. The capacitor charges 2 parts VCC through R1 and R2. When it reaches 2/3 VCC, the trigger comparator gives high output. This will set the flip-flop so the output becomes low and discharging transistor becomes on. So capacitor finds discharging path through R2 to discharge pin. As capacitor discharges to 1 by 3 VCC, the trigger comparator gives high output. This will reset the flip-flop, so output again becomes high and discharging transistor is off. So capacitor will again start charging. Thus capacitor will charge and discharge between 2 by 3 VCC and 1 by 3 VCC limits. This cycle continues and we get high-low output continuously at a rate of charging and discharging of capacitor. Monostable mode operation. Before trigger is applied, the capacitor charges to VCC through R1. When it reaches to 2 by 3 VCC, the teaser hole comparator gives high output. That will set flip-flop, so output is low and discharge transistor is on. So capacitor discharges and that's why output is low. When negative trigger pulse is applied, the trigger comparator gives high output. This will reset the flip-flop, so output becomes high and discharging transistor becomes off. So again, capacitor starts charging towards VCC. When it reaches 2 by 3 VCC, flip-flop sets and output automatically becomes low. So the output becomes high only when trigger is applied and remain high till capacitor charges to 2 by 3 VCC.
Assalamu alaikum sir, my name is Sumona Juthi. First and foremost, I would like to thank my teammate Tanjil, Hasan, Sakib for allowing me to present my skills. In today's presentation, our topic is the 555 timer and my part is about modes. There are three types of 555 timer. First one is stable modes, second one is non-stable modes, and third one is stable modes. Behavior of stable modes. The stable multivibrator is simply an oscillator. It generates a continuous stream of rectangular off-on pulses that switch between two voltage levels. The frequency of the pulses and their duty cycle are dependent upon the RC network values. The capacitor seizures through the series resistor R1 and R2 with a time constant R1 plus R2 into C. The capacitor discharges through R2. Behavior of non-stable mode. The non-stable multivibrator is constructed by adding an external capacitor and resistor to a 555 timer. The circuit generates a single pulse of discharge duration. When it receives a trigger signal, hence it is also called a one-shot. The time constant of the resistor capacitor combination determines the length of the pulse.
Assalamu alaikum, I'm Rahatullah. First of all, I'm gonna talk about the internal circuit. The blue components are three resistors, all of them are 5000 ohm. They divide the input voltage VCC into three equal parts. Then the red components are two comparators. They compare the voltages at their input and saturate them depending on which one is greater. Then the green component is a RS flip-flop, and the last one is the purple component is a transistor which acts as a switch which is connected to the discharge pin to ground when it is closed. Then we will see a simulation of 555 timer of stable mode. Here is the 555 timer itself. The reset pin is connected to the VCC. There is a resistor which is connected to the discharge pin and also to the VCC. There is one capacitor which is connected to the control pin and also to the ground. There is another resistor which is connected to this point and to another capacitor, and the capacitor is also goes to the ground. This is our stable mode 555 timer circuit. To see the output, there is one oscilloscope. The one point is connected to the output pin and another one is to the ground. To see the result, we have taken values VCC 5 volt, R1 5000 ohm, R2 22,000 ohm, C1 10 microfarad, and C2 100 nanofarad. There is the result of our simulation. There is a short clip of the simulation. So here is the result. That is all from me. Thank you so much for being with us.